All right, guys. Sometimes my students in the past, when I've taught, have told me that their favorite days are, well, actually, their favorite days are when it snows and I don't show up for school. But their favorite days when I actually show up are not days that I necessarily teach, but I just do problems. And that's kind of what we got going on here. I've got 11 problems that I'm going to run through with you, show you not only how to work these things, but how to think about them. So, and students, do they tell me oftentimes that they seem to get more out of this type of instruction than they do when I'm actually teaching, like, augmented matrices and things like that. So, guys, let's do it. Along the way, we're gonna use the calculator. I'm gonna use the overlay of the calculator today. So, I'll show you that when it comes up. All right. So, um, this let me kind of do this a little bit. All right. So this Jasmine chick wants to use milk and orange juice to increase the amount of calcium and vitamin A in her daily diet. An ounce, 37 milligrams. How many ounces of milk and orange juice? Okay. Now, when some students read this, there's just a lot going on, and they need to process the information. The first thing I tell students to do is usually you can go to the last sentence and identify what you need to solve. So for which you need to solve technically, but what you need to solve for. So I go to the last sentence and it says, how many ounces? So I know that my variables that I'm going to solve for have something to do with how many, right? I'm asked a question, I'm going to solve something, so obviously my answer needs to be what I'm being asked to solve. So how many ounces of milk and orange juice? So there's two things there. So the first thing I'm going to do is I'm going to identify my variables. And I'm going to let X be the ounces of milk. And I'm going to let Y be the ounces of orange juice. The next thing I'm going to do is I'm going to see that I have two variables. So I know right off the bat that I've got to look back into my problem and come up with two relationships that give me equations. Well, this is a situation where I get back to just a very simple premise that apples and apples have to be apples and orange juice have to be orange juice. Well, I can see that an ounce of milk contains 37 milligrams of calcium and 57 micrograms of vitamin A. Orange juice has so much calcium and so much vitamin A. Down here it says provide exactly 500 milligrams of calcium and 1200 milligrams of vitamin A. So let's focus first of all on this 500 milligrams of calcium. I know the calcium from the milk plus the calcium in the orange juice has to be the total amount of calcium. So my first equation is going to be for the calcium. So I have 37 milligrams for each ounce of milk. And again, I'm doing X is the number of ounces of milk. And then I have 5 milligrams for every ounce of orange juice. So I'll let that be Y. So my total calcium has to be 500. The next thing I'm going to do is I'm going to set up something for the other relationship that I'm given in there, or not necessarily a relationship, but the values, and that's the vitamin A. So I have 57 micrograms of vitamin A for each ounce of milk. And I have 65 micrograms of each vitamin A for each ounce of orange juice. I have a total of 1,200 micrograms of vitamin A. Now, I've got this set up, and I'll tell you, this part right here, the second part, is the hardest, because I've made it easy on you now with this whole augmented matrix thing. So the third step is to create an augmented matrix. Well, we saw from the previous video that the augmented matrix for this is going to look like 37, 5, 500, 57, 65, 1,200. So gang, if I put this into my calculator, I'm going to get the answer. So I'm going to use this calculator this time. If I can put that up there where... Yeah, that's not really too cool. Yeah, that'll work. So let's go second function into matrix. And I want to go over to edit first. It turns out I need a 2 by 3, so it's already set there. So I need 37, 5, 500, 57, 65, 1,200. Now, before I go any further, I like to just stop and take a deep breath, because I don't want to do everything right so far and then just make a stupid typo and end up missing. So I just go back through and check my 37, my 5, my 500. Just make sure that my values are correct. All right, second function quit. To get out of that, I need to go into this second function matrix. Go over to math, just like I showed you in the previous video. Come up to B, which is RREF. Go back to matrix and get my matrix A. Close it up with the right parentheses, and I get my values 12.5 and 7.5. Well, the 12.5 came first, so we've got our solution here, 1, 0, 12.5, and 0, 1, 7.5 from the calculator. And I don't know if you can read that or not, but this is the solution. So this right here stood for my x, because remember that we had our x's and our y's. So the first the first column was my x, the second column was my y. So this tells me that x equals 12.5 and y equals 7.5. Well, guys, since I clearly back in step 1 identified what this tells us, that x is the ounces of milk, I know that my solution is 12.5 ounces of milk and 7.5 ounces of orange juice. But guys, that's the solution to the first problem. And you can see that by learning how to do augmented matrices, that it makes the solution part of that very, very, very easy. Let's get into another type of problem. All right, so a small manufacturing plant manufactures riding lawnmowers. The plant has a fixed cost of $48,000, variable cost of $1,400. The mowers are sold for $1,800 each. Find the cost function. This is really, really easy, because There's really not a quantity given. It's actually just you have your fixed and your variable cost provided. So we need 1400 Q, which is our marginal cost or variable cost, and our fixed cost is 48,000. Easy stuff. The revenue function, R of Q, is just the amount that this lawnmower is sowed at times the quantity that is sowed. Now, set up a system of linear equations and transform your system into augmented matrix form. Now, what we're ultimately thinking about here is I want to let this over here be thought of as my y in both cases. So if I set this up as y equals 1400 Q plus 48,000, and this is y equal 1800 Q, what I could do is I could visualize this as what I've done before and kind of flip this to let well, I don't really want to flip it. What I want to do is I want to get it in a form that I've seen before, and that would be something where I have everything with my variables on one side and everything without my variables on the other side. So I could make this y minus 1400 Q equals 48,000. And I can make this one y minus 1800 Q equals 0. So again, I'm trying to learn from the past and trying to see that I usually have x minus y equal a number, x, y equal a number. So I want to get everything with my variables on one side and everything with my numbers on the other. What this allows me to do is allows me to set up the augmented matrix 1, negative 1400, 48,000, and 1, negative 1800, 0. All right. Now I'm going to put that in my calculator, and I'm going to use the calculator on the screen here for this one. So I'm going to go into matrix, go over to edit. I want to set this up as a 2 by 3. So I have 1 minus 1400, 48,000, 1, negative 1800, 0. Now take a deep breath, look back, make sure everything is set like it should. So I'm going to go second function, quit. I just did this for the previous problem, so I need the same command, just with different numbers. And I get something like this. And I'm going to write this down. I have 1, 0, 0, 1. So I have 216,000. And I have 120. All right, so I've written this down. Now I'll go back over and try to help you decide what this tells us. Okay? Now, so, guys, first of all, what was in the position of the columns? Over here, the columns were what? That was my y's. And my second column were my q's. So this was my quantity. So the second one right here tells me when my quantity is 120, my y is 216,000. But what did I do with this y? I made my cost and my revenue both y's. So if I have y equals y and I have my revenue equals my cost, which are what may equal to my y's, what does this tell me? Well, this tells me when my R of Q and C of Q are the same value. So guys, what we found here is nothing more than the value when R of Q equals C of Q, which is the break even. So it's just a kind of a fancy schmancy way of coming up with the break even point like we did before. Okay, now let's try that out. Before I told you we would find the break even point algebraically. And that's where the revenue equals the cost. Well, let's see. We had revenue is 1,800 Q. Cost was 1,400 Q plus, I don't remember, 48,000. Subtract the 1,400 Q from both sides. Divide by both sides by 400. So it tells us there that we have a quantity of 120 for the break even, which is exactly what we found back over here. But we'd have to put the 120 back into either the revenue or the cost, and it's going to be easier to put it in the revenue. So take 1,800 times 120, and you'll see that we get $216,000. This would have been equivalent if we had taken the cost of C of 120 which would also be 216,000. So that tells us when we sell 120 units that the cost at 120 units is the same at 216,000. So you can use augmented matrices to come up with a little fancier stuff. Well, you don't come up with fancier stuff. You just come up with actually maybe a little more sophisticated way of coming up with the answer. All right, gang. Here we have two different companies. And I told you earlier about drivers and putters for left hand and right hand. So apparently what's going on here, you've got two different companies, a plant A and a plant B. Let's say this one's in Ohio and this one's in Kentucky, just to give you some sort of reference potentially. Production costs for each instrument are given in the following. Plant A is matrix A, and Plant A is matrix B. So guys, at the end of the day, I say that a lot, don't I, at the end of the day. Matrix A looks like this. And matrix B looks like this. So guys, that 125 tells us what? That the production cost for the labor for each banjo at plant A is $125. So apparently the labor for banjos and the labor for guitars is cheaper the way I've set this up in Kentucky, and I just randomly chose that. But it's cheaper for plant B. Okay, so what we want down here is we want 1/2 A plus B. Well, guys, the A plus B part is really simple. We have two 2x2 matrices, so we're going to add the corresponding parts. So that looks like 103. This looks like 81. This looks like 174. And that looks like 240. So if I take half of that, half of 103 is 51.5. Half of 81 is 40.5. Half of 174 is 87, I hope. And half is 120. So guys, that's all you had to do in that problem. So that gives you an average cost of production in each plant. Now, it's important to notice that this sum, this average cost of production keeps the same format as these. So this was material, this was labor, and this was for guitars, and this is for banjos. So the average cost of materials for a guitar for plant A and plant B is 51.5. So the structure of the sum of the matrices stays the same, and then the corresponding parts mean the same thing. All right. Now, guys, this is a place where this is probably the most important problem I'll do in this video. The others are important, but this one really focuses on something that's important. So what it does is right here. We've organized our measurements here. So matrix M gives the protein, carbs, and fat for cereal A and cereal B, and matrix N gives cereal A and cereal B of mix X, mix Y, and mix Z. So the question here is, does M times N exist? Well, we can look at M and we can see that M is a 3 by 2 matrix. And we can look at N and see that this is a 2 by 3 matrix. So these two numbers have to be the same, and the product matrix will be a 3 by 3. So yes, it exists, and the product will be a 3 by 3. Now let's come down here and look at N by M. So N is a 2 by 3, and M is a 3 by 2. So yes, it also exists. But does either product mean anything? Now, guys, let me explain what I mean by that. And again, this is huge. This is probably the most important thing I'm going to teach in this video. What we got here is both exist, but are either meaningful. Do either have a meaningful interpretation. So the way you determine this is our first matrix A times our second matrix B in general. Now again, remember, this is we're just going to call this an M by N, and we're going to call this an R by S. For the product to exist, N has to be equal to R. But guys, when we get into applications, we need to know, are they meaningful? Must measure the same thing. Okay, now let me tell you what I mean by that. Let's go back here and look at the first the first situation. Okay, guys, I know this gets a little, this is more complicated. This is the hardest thing that we're going to do in this video. Now, right here, we see that MN does exist. But when I take M, I have proteins, carbs, and fat, and I have cereal A and cereal B. When I take this matrix in, I have cereal A, B, but I have mix X, mix Y, and mix Z that come from these. For this product to be meaningful, not only do the number of columns, the 2 right here, have to be equal to the number of rows right there, but they have to measure the same thing, and they do. They're both measuring, they're both give values for the type of cereal. Therefore, when we create the product matrix, the rows, there's 3 right here, not only the values come from using the rows of the first matrix, the interpretation comes from using the first matrix. Same thing here. The interpretation comes from the columns of the second matrix. So for example, when we multiply these two values, these two matrices together, this value, whatever number goes right there, is going to tell us the total number of carbohydrates in mix Y. So these values are going to be meaningful. Now, let me give you an illustration of where it wouldn't be meaningful, and where we can't interpret. Let's change it. Let's put this over here. So what I'm doing now is I have taken N times M. Now, arithmetically, if these are just generic matrices, I can multiply those because this is a 2 by 3. This is a 3 by 2, so these values are the same. But for the the elements of the matrix to be meaningful, to have some sort of meaningful interpretation, what we're measuring on the columns has to be the same thing that we're measuring on the rows, and it's not. This is a mixture. This is protein, carbs, and fat. So arithmetically, we can put these or mathematically, I should say, we can put these matrices in our calculator and hit multiply. It'll give us a value. It's just these entries in here don't mean anything to us because the condition of what the rows are measuring on the first matrix and what the columns are measuring on the second matrix doesn't coincide. So it does exist, but it's not meaningful. So guys, at the end of the day, the very first part A, we ask MN, and let's just create our own matrix here, if you will. Does MN exist? Yes. Is it meaningful? Yes. Because our columns and our rows, our columns of the first matrix, our rows of the second matrix are measuring the same thing. NM, does it exist? Yes. Is it meaningful? No. Our interpretations don't mean anything because the columns of the first matrix and the rows of the second matrix are the same number. There's 3 of each, but they're not measuring the same thing, so the interpretations are not meaningful. So gang, what I want to do is I want to go in and I want to find the matrix. So the easiest way to do that is use your calculator. So let's do that. So what I would do is I would come in and I would set up, I mean you can use M and N, but I'm just going to let matrix M be the first matrix. So I need a 3 by 2. So I have 4, 2, 20, 16, 3, and 1. All right. Now, second function quit. Go back into matrix. Scroll over to edit. We'll come down to B and we'll set it up as the N matrix. Now, guys, this is a 2 by 3. So we have 15, 10, 5, 5, 10, and 15. All right, let's get out of there. Now, what is relevant? Let's do A times B, which is the M times N. We know we're going to get what? A 3 by 3 matrix. So A times B. So guys, we know from what we saw earlier that for example, I concentrated on that center number, 360. So that would be the number of carbohydrates in mix Y. Because again, one more time, all right, I'm going to be redundant here because this is harder stuff, okay? When we put our first matrix, we had protein, carb, fats for AB, cereal A and B, and then matrix N, we had cereals A and B, but we had this mixture X, Y, and Z. We have a 3 by 2. We have a 2 by 3, so this stuff all matches out. But not only does it have to match out in number, it has to match out in what it's measuring. If it does, then our product matrix comes from these two things. We know from this that it's going to have 3 rows, and this information is going to come from the first matrix. This is going to have 3 columns, and its information is going to come from the columns of the second matrix. So I have a 3 by 3 P, C, F, X, Y, Z. So that value that we saw in the middle on our calculator, which was 360, and I'm just going to write all these down. Now, if you're sitting here watching these videos and you got reruns of Friends on or Seinfeld or whatever, it's probably not going to work. This is going to take more thought than you giving this half of your attention, or maybe not even half. This is harder. Okay. So, for example, that 30 right there tells us what? The grams of fat in the mix X. Now, the other doesn't work out. It doesn't work out that way because the columns of the first matrix and rows of the second matrix are the same number, but they're not measuring the same thing.